On the back, we are looking at sigma notation, which is a way to write a series. A series is a sum of numbers. So you're taking the sequence and adding all the numbers together. So you can see the difference here. We have plus signs between the numbers, which makes it a series and not a sequence. And we're going to express this series as a sigma. This is the capital Greek letter sigma, and we would call this sigma notation, or sometimes we call it summation notation because we're expressing it as a sum. And for this series in particular, we see that we're multiplying by 3. So the rule would be 3k, and k equals 1 goes on the bottom, and then we put 10 on top. And why is it that? So the bottom tells you where to start, and the top tells you where to stop, and it's referring to k values. So here my k values are the term that we're on, and we see that we're going from 1, 2, 3, 4, all the way to 10, to term 10. And then the top number, again, we're stopping at 10, so that's why there's a 10 on top. And we see the k is being multiplied. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, 10 times 3 is 30. So that's why we have 3k. The term value is the number you actually get. So that would be the 3, the 6, the 9, the 12, and then all the way to the 30. So that is sigma notation, and now we're going to use it in example 4. It says write each expression in expanded form and then find the sum. So they want us to start at 1, plug in 1 for our k, and then they want us to plug in 2 and 3 and 4. I'm stopping at 4 because that's the top value of the sigma, so it tells me to start at 1, stop at 4. And I'm putting plus signs between them because that is what the sigma tells me. Sigma tells me sum, so we're adding them all up. So we have -3 plus -6 plus -9 plus -12, which makes -30. So that is the answer. So let's try B, unless you want to pause the video and try it on your own first. So this would be plug in 1, then we plug in 2, then we plug in 3, and then we plug in 4. And I'm getting, for this number, I'm getting 3, and 4 plus 1 is 5, and 6 plus 1 is 7, and 8 plus 1 is 9. And you add those all together and you get 24 for B. For C, you can try it on your own if you want to pause it, but you plug in 1, plug in 2, plug in 3, plug in 4. And here I'm getting 3 minus 4 is -1, 6 minus 4 is 2, 9 minus 4 is 5, 12 minus 4 is 8. Add them all together and you get 14. This one's a little different. It starts at a different number. It starts at 4 this time and ends at 6. So we start by plugging in 4, then we plug in 5, and then we plug in 6. So that gives me 16 plus 1, which is 17. This gives me 32 plus 1. And this gives me 64 plus 1. And we add all those together, we get 115. 115. And then in example 5, they give you the series and they want you to write it in sigma notation. Now, when you write it in sigma notation, even though sometimes it can start at other numbers besides 1, I want all of your answers to start with 1. That way we're all getting the same answer. And it doesn't have to be K. You're going to see different letters used for sigma notation like I and N, but today we're just using K. So we've got K equals 1. And so what I like to do is put a little 1, 2, 3, so I can think about what my K values are and how I'm taking these values to get to 4, 6. So what am I doing the 1 to get 2, 2 to get 4, 3 to get 6? And what I'm doing is taking that K value times 2. So my rule is 2K. The rule is what goes off to the side. And if my rule is 2K, then what is my K value making 128? So that'd be 64. 2 times 64 is 128. So my ending number is 64 on the sigma notation, and that's what they want you to write. So let's look at this. I've got sigma starting at 1, and so then I'm going to put a little 1, 2, 3, and then I don't know what I'm ending with. But if I look at my numerators, I see that 1 is 1, 2 is 2, 3 is 3. So that means the top number is just the K value. Then I look at the bottom. What did we do from 1 to get 2, 2 to get 3, 3 to get 4? And we're just increasing the K value by 1. So K plus 1 is my denominator. And if K is the top number, and my top number is 13, then that means I'm ending at 13. So that's what I want for B. Then C is a little bit more challenging. So let's start at 1. And if that's 1, then that's 2, 3, 4. And we want to think about what are we doing from 1 to get 1, 2 to get 1/3, 3 to get 1/9, and 4 to get 1/27. And so if you think about the fact that these all are multiples of 3, but we're not doing 1 times 3, 2 times 3, 3 times 3. They all have a 1 on top, so we can start with that, 1 over something. And so we think about, well, is it 3 to the K? 3 to the first is 3, 3 squared is 9, 3 cubed is 27, but it's 1 less than that. So what we're seeing is it's 1/3 to the K minus 1, 1 less than that. So let me show you what I'm talking about. If I plug in 1, I get 1/3 to the 1 minus 1. 1/3 to the 0 is 1. If I plug in 2, I get 1/3 to the first, which is 1/3. If I plug in 3, I get 1/3 squared, which is 1/9. And if I plug in 4, I get 1/3 to the third, which is 1/27. So then I have to figure out what am I plugging in to get 1 over 2,187, and that would be 8. Because 1/3 to the 7th will give you 1 over 2,187.